This presentation is going to be an overview of the analysis of the F Black Mountain bike frame in two different materials, steel and aluminum, by James Garrett and Jacob Sharetta. This is an overview of the materials and tube sizes that were used in this project, a 7005 aluminum alloy and an SAE 4130 chromoly steel alloy. The aim for this project was to get the different frames below a certain reference frame weight, and as shown in the bottom right, the final weight of the steel frame with those cross sections was 4.97 pounds, and the final weight of the aluminum frame was 3.5 pounds. For our first static case, we chose to analyze a rider coasting while standing out of the saddle, supporting their weight on both the pedals and the handlebars. The loads and constraints are shown on the left, and the diagram of the loading is shown on the right. For the remainder of these images, the total deformation will be shown on the left and the combined stress will be shown on the right. This is an example of the steel analysis for the coasting scenario. This is the aluminum analysis for the coasting scenario. For our second static case, we chose to do a frontal impact scenario where the back of the bike is essentially fixed and the load is applied below the handlebars. Again, the loads and constraints are shown on the left and the scenario is shown on the right. This is the enumeration for the steel frame. This is for the aluminum frame. The third static case we chose to analyze was a 1 meter fall. This had the same essential application of loads and constraints as the original loading case, the coasting case, but the magnitudes of the loads were greater because of the greater acceleration due to gravity. Again, this is the steel analysis, and this is the aluminum analysis. For our fourth static case, we chose to do a rear wheel perpendicular collision, where the load is applied perpendicular to the planar axis of the front of the frame. This is the analysis for the steel. This is the analysis for the aluminum. For an overview of the static analysis, it can be seen that the maximum stress in the steel frame was larger on all accounts than the aluminum frame. This is because the cross sections of the steel frame were much smaller and the tubes were smaller themselves, even though the weight was higher. Also, one can compare the coasting scenario and the 1 meter fall, and it can be shown that in the 1 meter fall, the magnitude of the forces were greater, so the stresses are greater. We then performed a buckling analysis on two different loading cases, the first one being the frontal impact. As shown here, there are two different buckling modes, one for the steel on the left, one for the aluminum on the right. The aluminum's buckling is more pronounced than the steel's because it has a lower stiffness. This is the other buckling mode, a 1 meter fall, and again, it can be seen that the aluminum's buckling mode is more pronounced because it's less stiff. We also analyzed certain joints. This one is the front joint below the handlebars for the frontal impact scenario. The total deformation and equivalent stress are shown. This is the aluminum frame with that same analysis. We also analyzed the center joint where the pedals are held for the 1 meter fall in the steel and aluminum. For an overview of our buckling, we also did modal analysis on the steel and aluminum frames, and the natural frequencies are shown here, and these are the aluminum frequencies.